Fine, guys. So, in last class, we have seen different types of machine learnings, right? So, what are those? Supervised, unsupervised, semi-supervised, and reinforcement. Okay, but the most important one are supervised, unsupervised. Okay, and semi-supervised will be a subset of these two anyhow. Fine. So now, what is the fundamental difference, guys, between supervised and unsupervised? Supervised will have both X and Y. Training will be done, right? And then predictions. But in unsupervised, there will be only X, fine. And this will be for the clustering. Okay. So I hope we are good with these points. Okay, fine. Now, going forward, we'll see few more concepts in the machine learning. Okay. Now, whatever be the machine learning, fine. So finally we are going to generate a model, guys. Getting? So over here, in each, as I said, in each one from this type, okay, whether supervised, unsupervised, we have different sorts of algorithms, fine. So, and when you use any one of those, finally what you get is a model will be getting created. Agree? So now this model, once it is generated, fine, that model generation and the whole learning process, okay, can be done in usually two ways, guys. Okay, one is online learning and one is offline learning, fine. So these are just general concepts of ML. Okay, so now over here, what is the difference between offline learning and online learning, or what do I mean by the word learning over here is, see, first of all, let's, if we consider offline learning, what happens over here is you have a data, fine, you have data, you do all the required pre-processing, okay, you do all the required pre-processing, fine. After that, you do the model training, okay, model is generated, fine, locally, okay, all this is locally, okay, or you can use any cloud also, but for example, if we take locally, okay, you have generated the model, okay, you have done the testing, okay, and the model is good. Now what you are going to do, you are going to push this to push this to where? Server. Okay, okay, server. So over here, what happens? Okay, see, let me actually start my video so that it will, sorry guys. Okay, so over here, as I said, one is online learning, offline learning, right? So usually what happens over here is, yeah, so usually what happens over here, once you generate the model, right? So once you generate the model and you test it, and if you're convinced with the accuracy, fine, if you're convinced with the accuracy, what happens, you will push it to some server, okay, and you can hand over it to a client, okay, as an example. Okay, if you take an example, let's say you got a project from hospital, okay, and you have, and there is some use case, machine learning use case, fine, and regarding that, you got the data, you done all the required processing, okay, and model is generated, testing good, giving good accuracy, okay, you felt, and then you have pushed it to server, okay. And what happens after you push the model to server? So now it will be running on the actual data, all right. So what are the dynamic data, live data, right? So what are the data the hospital gets on in real time, okay, the model will be getting exposed to that, it will be doing predictions based upon that, Okay, as a simple example, let's say a simple disease detection. Okay, fine. So the model the hospital has already given you a lots of data based upon the symptoms, fine, and the previous medication what he has undergone. Okay, and the output will be or type of disease, whether it is, let's say, cancer or diabetes or something. Okay, that the disease detection. So you have trained the model, fine, accuracy is good, and once that is done, you have submitted your model so that the hospitals can deploy it in their servers. Okay, where their websites can pick it, fine. So that is done. Okay, so everything you have done locally, and then you have passed it to the hospital servers. Now once it is done, so what happens? So now whenever someone logs into their website, fine, and then they enter their symptoms, fine, then those data will be passed to our model, okay, which is in their production environment, fine, and it will be giving predictions based upon the training, fine. This is a normal scenario, right? Are you getting this?
Yes.
Fine. So this is called as offline learning, guys. Okay, that means what? So you are doing everything locally, fine. You are doing everything locally, and then you are passing the model. Okay. So once the model is passed or submitted back to the client, you lose control over that. Fine. So now whatever it has got trained upon, so it will be giving predictions based upon that training only. Fine. So you lose touch with the model. Agree? Now, what happens over here is if you see the advantages is, so you can do all the required training part, programming part locally. Okay, you have that feasibility, fine. And but the problem here, if you think over it, for example, let's say uh, till 2020, okay, so all the diseases which we are aware of are everything except corona. Agree? So the model which you have trained, fine, the model which you have trained uh, locally, okay, till that particular year, fine, so we'll be exposed to only diseases like what? Heart attack, cancer, etc, etc, fine. So you have trained that and you have submitted the model, fine, and now it is working with the hospital website. Now suddenly in 2022, so we got exposed to a new, okay, virus or disease, corona, fine, and people got affected with it, fine. Now from, okay, so just a second, someone is asking a question. I have a doubt, is this necessary to show accuracy change everyone? Accuracy. See, Sirisha, so try to ask doubts related to what I'm discussing, right? So because we are learning, I'm discussing online learning and you are asking something related to accuracy. Did we start accuracy? No, right? At least did we start models? No, right? So once we are done with general concepts and once we start models, fine, then we will learn about the accuracy. Sir, you have about patient data. Yeah, patient data. See, you said yes, patient data, but in from what point of view? Only from the online learning or offline learning, right? So accuracy, first of all, did I discuss about accuracy? So without that, if you ask like, sir, everyone says accuracy, accuracy, and how is related to accuracy doing ML projects? We can do, see, there are like a lot of things, right? Accuracy, you have precision, recall, F1 score, right? So we can't discuss in the middle of this, right? Okay, fine, fine. It's okay. But what I'm saying is, if I start discussing that, right? So obviously that will be off the track. Fine. I need to discuss so many things. So don't worry. Whatever you have in your mind, right? So we are going to discuss each and everything. Fine. So I can directly jump. So that's fine. See, I can directly start off with the ML algorithms. My idea was that, okay, to start with the feature engineering and ML and then go to different algorithms. But I thought that starting from scratch will be definitely beneficial for you. Okay, so that's fine. So no, that's fine, Sirisha. But whatever the words you have heard about machine learning, right? So we are going to discuss each and everything. Fine, every algorithm, fine, and every metrics, fine. Not only accuracy. So as I said, every regression accuracy, classification accuracy, everything we are going to discuss. Okay, fine. Because if I start discussing this, fine, so we will be okay getting diverted. Fine. So fine. So ask doubts, but try to ask like from the concept which we are currently discussing. Okay, cool. Now coming back, yeah. So as I said, our model is trained only until 2020 data, which it is not exposed to corona. That data, fine. Now, what happens in offline learning here is, so we have already submitted the model to the client, okay, and it is running fine. And after 2020, let's say March or something, okay, so the cases went up, and everyone, most of the people got affected with corona, right? Now, those people who got affected, so if they start submitting, fine, their symptoms, etc. Obviously, the actual answer should be corona, fine. But did our model got exposed to corona data? No. So obviously it cannot predict the diseases corona. Why? Because model can predict only based upon its training. Okay. If it is not present in its training, fine. Obviously it cannot predict. Okay. How can it tell something which has not, which it has never seen it in its lifetime? Fine. So that is a problem with the offline learning. What? Because in those cases, what we need to do, we should again train the model locally, okay, and pass it to the client, and they will redeploy this model in this server. So once in a while we need to constantly check the accuracies, fine, constantly check the accuracies, and then we should start retraining the model and then redeployment. Okay, so this is a continuous process which takes place. Okay, and most of the projects are like this, fine. Even one of the project which I worked in my previous company follows exactly the similar procedure, fine. So it was related to insurance claims, and we have done all the things which I have said, and we have submitted the model, and it is deployed, and we will be checking the accuracy in the production environment. What do I mean by production environment? That means it is working on the real data, fine. So when we are training the model, okay, we use a sample data, fine. So that means it might be historical data 2 years back, 3 years back, fine. So once the model is trained and we have it is deployed in the production server, it will be running on the actual data. That means dynamic, like live data, right? If today morning, if I open the website now and submit something, it will directly go to the model, and the predictions will be coming from the model. Okay, so it's a live data, fine. So that is a concept of offline learning, fine. So once you deploy the model, so you don't have any control over it, fine. So again, you need to test the accuracy over there, okay. And if it is, let's say, dropping below 80 or some threshold you can keep, you need to again start the process of retraining and redeploying, okay, or remodeling everything, fine. Are you getting, guys? You got any idea, uh, some idea regarding offline learning? What?
Yes, Santosh.
Mm, others? No?
Yes, sir.
Okay. So if you're not getting, feel free to say no, that's fine. Mm,
Repeat it again, sir.
okay. So then why did you say yes, Sirisha? Okay, fine. See, in offline learning, what's happening? It's a general. So what all the process? Fine. So what all the machine learning life cycle that is happening locally, right? So that is happening locally, and the output of this is the model. Right? The output of this is the model. Okay, and this will be deployed in some server. Okay, this is deployed on the server, and this will be working on the live data. Fine. Now, once this is deployed over here, fine, that means what? Its training has already stopped. Fine, the training stopped over here. Once a model is generated, fine, the training is stopped. It is not getting trained anymore because the model is already generated. So we will take this and deploy it in some server, and we'll start using this. Okay, we'll start using this. Fine. Now, let's say this is data D1. Fine. So this model is trained on data D1, and let's say we got model M1. Okay, so it can do predictions only the data similar to D1. Okay, because it is trained only on this data. Fine. Now, if this data is changing, fine, if the data is changing, obviously we should retrain the model, because if it is not trained on a particular data, how can it do predictions on that data? Fine, because I'm saying while training we have shown the model only the diseases like heart attack and lung cancer, for example. Okay, we have told that whatever with the symptoms, the disease could be either heart attack or what, lung cancer. So it understands that there are only these two diseases in whole world. Agree? But after few years, if a new disease arrives in the market, fine, if you're not training the model, fine, on the data, new data, obviously it cannot understand. Simple, right? It's as simple as that. If you don't expose it, it cannot learn. So for that, you need to again do the data collection, and then again do the model building, and then redeploy. Fine. So this happens continuously. Fine. Every once in a while, you will be checking the accuracy from the live data, and if it is dropping, again you will start this backend process of data collections, trainings, processings, okay, and then model validations. And once again new model is generated, you will deploy this new model. So already in server you will have some model M1. Fine. Now if this data is changing, that means if this becomes D2, you will do all the process, you will get model M2. Fine. Now this you will deploy this, that means this M2 will go and replace this M1. Okay, now you will remove this M1 and you will replace with this M2. Now this M2 is little more powerful because it got exposed to the latest data. Getting this?
Yes, sir.
Okay, fine. But here the problem here is, as you have seen, every time the data is changing, you need to again retrain it. Okay, fine. But however, this is the most common approach. Okay, usually we follow practically. Fine. Now coming to online learning, okay, at a high level, everything is same. Okay, everything is same. But here, once a model is deployed, okay, fine. So the predictions, okay, can be extracted, okay, from this model. Okay, predictions will be happening parallelly, side by side. The model also gets learned. Okay, so that is called online learning. That means what? You don't need to again retrain the model. Okay, once you have trained the model and you have placed it in the server, so obviously it can be used for predictions. Okay, simultaneously the model also gets learned and becomes better and better. Okay, so one example is the famous ChatGPT. Agree? So what they have trained it on huge amount of data, fine, for some years, fine, and then they have built the model called ChatGPT. Fine, now we have this model. Now they have deployed in their servers. Who servers? Who owns ChatGPT? OpenAI. Okay, so they have their servers and they have deployed it in their servers. Fine. Now everybody is using. Agree? Now what is happening with ChatGPT? As more and more people are using, it's becoming better and better. Fine. The answers which it is giving, the mistakes which it is making are decreasing. Fine. And the suggestions which it is giving are becoming better and better because it is learning from the inputs also. Fine. So that's called online learning. That means along with predictions also, the simultaneous learning or training process is also happening. Fine. So that is where you have this online learning. And one more simple example, if you observe, you have in your keyboards Swift key. Fine. So for typing, so if you usually if you don't want to type, so we slide through the keys. Fine. You know the Swift key. Anyone know Swift keys? No. Yeah. So we have this, right? So Swift key. So you can slide through. Yeah, this is a perfect example. See, you can slide through the keys. Okay, you can slide through the keys so that it gives you the word. Okay, so now what happens if you observe? I have observed as you use it more and more, it becomes more accurate. Okay, so it learns. Fine. So if there are, for example, if there are some words which you frequently use, okay, so as you use them more and more, the other time it will also predict the word. Okay, so what do I mean? So for example, let's say you can also try it. Okay, I observe it every time. Okay, so for example, let's say you have typed this message, hi, hello, how are you, I am fine. Okay, now let's say you want to send this message to 10 of your friends. Okay, so you open your WhatsApp. Okay, you have opened first friend chat and you have typed this message, hi, hello, how are you, I am fine. Okay, and now let's say you have sent it. Now come to friend number 2, open this chat, and when you press hi, it will suggest you the words which you have just typed. Okay, you will say hi. Next you can say suggestions, hello, how are you. Okay, it may not be that better. Okay, but mostly it will try to suggest the words which you have just entered in your chat number 1. Now by chat 3 or chat 4, okay, you can see the accuracy is very good. Okay, so I have practically observed. I'm not sure whether you guys use this feature in keyboard or not. Okay, but I use this, so it is very easy. Okay, for typing. Okay, so any new word, okay, so you use this, right, it will start predicting it. Okay, so the sentence, okay, for example, if I say something like machine learning, okay, course is going on. Fine. So once you use this text, right, so it remembers it. Okay, and then the next time when you type machine, fine, it will suggest learning. Okay, when you say is, it will suggest going. Fine. So the more you use it, the more better it becomes. Fine. So that means we are not training it separately. Fine. So as it is doing predictions, it is also learning simultaneously. Okay, so this could be one example. Okay, so those are the two things is, okay, one is the the only difference in online learning is it can also learn, okay, without being remodeled or retrained. Okay, so but offline learning is the one which we have discussed. Okay, so fine. Any doubts, guys? Meghana, are you getting?
Yes, sir.
Okay.
Understood.
Okay. But as I said, these are general concepts, right? These are not like any specific algorithm related. Okay, these are general. So you will have a better understanding once you start working. Okay, so what all discuss things which I'm discussing in today's class, right? So you will remember this when you actually start working in a project. Fine. So these are the project related general topics. Okay, but it is helpful for you to know. Okay, fine.
So,
Yeah, Karthik.
So where exactly it will be different, Santosh, online and offline? I mean, not about like training wise. I'm not talking about. It will be trained automatically online. Offline is like again we need to take back the model into our local, and again we need to give the new training data. Again we need to deploy in the server. That is the case with offline, right? So while developing model, we'll use different techniques for this online offline, or how it will be. I
Yeah,
mean, I'm
yeah,
talking about
I got your question, right? No, the model related part, everything will be same, okay? But for online learning, okay, I remember because I did not like use the online learning approach, okay, because it is very cost effective, guys. Because it is, if you want to do the online learning, right, that means what you should, the architecture will be a bit different, okay. So online ML libraries, there are some, something called as Rabbit or River. There is a River is a Python. It aims to most user friendly doing for the online machine learning on streaming data, okay. So the model, data processing, everything will be same, okay. So because model is model, whether you train it locally or whether you train it online, is model, okay, that's not going to change, okay. But to help with some setups, okay, that means what, so it's to make it learn simultaneously, okay, from the live data. So obviously the pipeline will be little different, okay. So for that you have this library called as River, okay. So this will help it to, you know, learn it while also training it, okay. So but to answer your question, like where it will be different means everything will be same, okay. So most of the things what we are doing in the offline, the same thing will be done in the online also, okay. But only to make it, okay, to learn from the online data or the streaming data, fine, and do the predictions, okay. So you might need few other libraries, okay, like River, okay. River is one of the library, and uh, whether it is one more thing is, I don't, is it Rabbit, Raspberry Pi, well, not Raspberry, but yeah, River, okay. So you can, yeah, you can go through this everything, okay. But I'm saying mostly you're not going to use online learning, okay, because it's more bit complex and it is more cost effective. But usually companies won't encourage using online learning, fine. But if you're interested, you can go through this library, okay. So where it discusses like how like incremental learning and continual learning, fine. So that's what we have discussed, right? So it's not like once we have trained the model, it has learned and we have deployed, okay. We have done that, but again once it is deployed also, it learns incrementally, okay. It learns again and again, okay, and continually it learns, fine. So that's regarding the online. So does this answer your question?
yeah, Santosh, got it.
Okay, fine, guys. So after that you have something called as instance based and model based learning, guys. Now what are these instance based and model based? Now see here, see the models which we have, which we are going to learn, okay. So you have different models, fine. So in those, some are instance based and model based learning. So what does this mean? Model based are, for example, the I'll tell you with an example, okay. So for example, if you take the model based, the other day we have seen this, I've given you a brief about linear regression, okay. So when you are drawing reg plot, fine, in Seaborn and Matplotlib, when you are drawing reg plot, regression plot, so I was telling you about the linear regression. Okay, so over there what happened is, okay, over there what happened, what was can someone tell me what was a model in regression model? In linear regression, what is a model? What is the final output of linear regression? I know we not discuss it yet, okay, but when we're discussing that plotting, right? So I have told, let's see if anyone of you remember.
We need to draw a line with the minimum number of
Perfect.
minimum distance, sir.
Perfect. So the model here is line. Okay. So finally, what we are going to get a line. So now, if you're having doubts like, sir, how the line could be model, etc. So all those are going to be answered. But as of now, just understand that linear regression, the output is model. That means what? The equation of the line. Fine. So when see, did I just draw over here and explain, or yeah, perfect. So you're having this, right? So this is a linear regression I have said. Now over here, this line, okay, this line is the model. Okay, so who is going to give this line? The model is going to give. How it is going to give, that we are going to see. Okay, so how it is going to find out the best line. Okay, it's called best fit line. Okay, that means this is the line which is as much which is at the minimum distance as possible from all the given points. Fine, so it is going to give you the line. Now the equation of this line, okay, each line will have its equation, right? Or you can take y is equals mx plus c, okay, for example, right? So this equation of the line, once you have, so now this becomes a model. This line is the model actually, fine. So now these types of models, okay, so these types of models, okay, where you have actually a model is getting generated, fine, where a model is getting generated, fine. Those are called model based learning, guys. Okay, so that means what? In for example, in linear regression, if you take in linear regression, the model is line. Okay, based upon line, it is going to what? Based upon line, it is going to give the predictions. That means any new data point which we are going to give to this. Okay, so once this line is generated, now if you are going to do some prediction, that means let's say a new test data point is over here. So the predictions will be coming up from this line. Okay, the predictions will be coming up from this line. Okay, what is the distance from this line to this point? Okay, and also if if a new data point is over here, so it will be doing predictions from this line. Okay, so the line is generated, that means a model has been generated. Okay, so when a model is actually generated and which it can be used for predictions, okay, those types of models learning is called model based learning, guys. Okay, you will understand the difference, don't worry. Just give me few minutes. Okay, now even in logistic regression also, okay, so there is another model called as logistic regression. Okay, now here also the model is line. Okay, now you're not learn logistic regression, but just to give an one line definition, the logistic regression is a classification algorithm. Okay, so what it will do, given data, it will classify. Okay, these are type 1, these are type 2, or these are class 1, these are class 2. Obviously it is doing classification. Now how it is going to do the classification? Okay, there also you will have a line. Okay, so there also you will have a line. That means what? So over here, let's say these are type 1. Okay, these are some type 2. Okay, so it will draw a line and will say, hey, above this are type 1, above below this are type 2. So again, you are having a model in the shape of line. Okay, so that means a model is already generated. Model is getting generated. If you have this equation of this line, using that line equation, you can do the predictions. That means you are having model in your hand. Okay, so this is also a model based learning. Okay, why we are generating the model, right? And then you have, let's say, decision trees. Okay, from the decision trees itself, you have all these branches, like you will get random forest, you will get bagging, boosting, ensemble learning, okay, AdaBoost, okay, XGBoost, okay, etc. Okay, but at grassroots level, the model over here is a decision tree. Okay, so over here in decision tree also, okay, in decision tree also, you will have the model in the shape of a line. Okay, so those will be actually all perpendicular lines. Okay, for example, you have something like this. Okay, fine. So the model will be in the shape of, like, first it will draw a line over here, next it will draw a line over here. Okay, next it will draw a line over here. Okay, so over here it will be the predictions, the divisions between these models will data will be this. Over here also you have a line. So the common point over here is you are generating a model, whether it is a line, okay, or something else. You have a model in your hand which you can use for predictions. Okay, that means what so the one important point you need to understand over here, okay, that slowly you should start thinking, okay, from machine learning point of view, guys, from the training point of view. Okay, so all these are interrelated. Fine, so slowly you should try to connect all the words which I'm speaking and, okay, understand. So here what I'm saying here is, when you say model training is done, okay, I'm saying you have a model in your hand. Okay, when you have a model in your hand, what does that mean? That means the training is already completed. Fine, once the training is done, now there is no need for the data. Fine, so మనకి డేటా ఎప్పటి వరకు అవసరం? ఓన్లీ మోడల్ మన చేతికి వచ్చే వరకు అవసరం. Okay, once a model is already trained and you have the model, okay, now there is no dependency on the data. Because why? Because if you have a new test data, obviously you have model in your hand, you will pass the data to the model and model is going to give you the predictions. Is this clear, guys? Are you guys getting? Are you able to understand my words, or is it like off air? You're not getting anything?
Fine, Santosh.
Fine. Okay. So now over here, as I said, the model will be generated, but there will be some other types of models. Okay. So coming to instance based. Okay. For example, you have a model called as KNN. Okay. For example, you have a model called as KNN. It's called K nearest neighbors. Okay. So over here, what happens is, I'll just give you a basic idea as of now. Okay, so over here, what happens is, so if you have different categories, okay, if you have different categories over here, okay, and if at all, let's say a new person has arrived, okay, let's say a new person has arrived over here, okay, so based upon the nearest neighbors, it is going to do the prediction. Okay, based upon the nearest neighbors, that means how close is this to this neighbor. Okay, what is this? One of the neighbor is this, one of the neighbor is this, one of the neighbor is this, and then one next neighbor is this. Okay, like if you consider 4 nearest neighbors, out of 4 there are 2 stars, so there is a probability that this new item is also can be a star category. Okay, or for example, if you have one more circle over here, so now the nearest out of 4, the nearest 2 neighbors are circles, so there is a probability that this new test data set could also be a circle. Okay, so it depends on the neighbors concept, nearest neighbors. The KNN stands for K nearest neighbors. Okay, now over here, if you have observed, we are not doing any specific training, guys. Okay, we are not doing any specific training. Okay, we are using the whole data, we are calculating the distance, and then we are assigning the category. We are not getting any model generation, we are not getting any line or equation, nothing we are doing. Okay, so the model is the whole data itself. Fine, so overall data will be used for the predictions. Getting this? Are you getting doubts? Okay, fine. So see, this is just where I'm just using these as examples. Okay, but we are going to see what each of this model in depth. Okay, but the nature of this model is it is not going to generate any model. Okay, so it will just, if you given a new input, okay, first if you have 1 lakh points, okay, it will just scatter the points all over the space, and no, that data is present. Now if you just give one more new test data set, Okay, based upon the values, input values, it will plot that data point, okay, in this 1 lakh data point space. And then let's say if you consider 4 or 5 neighbors, it will see what are the 5 neighbors for our test data set. Okay, and in that 5 data points, what is the maximum category, or category 1 or 2 or 3. Okay, if 2 is a maximum category, it will just mark this new test data set as category 2. So it is not learning anything. Are you getting this? Is it learning anything? It's not learning anything. It is just based upon specific instance. It is calculating the neighbors and giving the prediction, and that is done then and there itself. If you get new test data set, again it should learn from scratch, that it should again calculate the neighbors distance, and then it should categorize. Again new data set, again calculate new. That means what? It is having complete dependency on the input data. If you remove the input data and if you pass new test data set, it doesn't work, because if there is no data, how it is going to calculate the distances? Following?
Yes, Santosh.
Yes, sir.
Okay, so to calculate the distances, obviously it should have some data, right? So and what is the data? Input data. Fine. So if you remove the data and if you pass the sample output test point, obviously there is no prediction that is happening, because there is no data to calculate the distances. Fine. So that means it is having 100% dependency on the input data. Why it is having? Because the model is not getting generated. Fine. So that's the difference between instance based and model based. Okay, instance based and model based learning. Okay, so we are going to understand what are instance based models and model based models. Okay, most of the models are model based models. Okay, so all the linear regression, is a logistic, or even the k-means clustering. Okay, so everything will be a model based learning. Okay, but one of the example of the instance based is KNN. Okay, so but don't think that model based are better than instance based. No. Okay, based upon your data set, sometimes KNN can give you the best accuracy or results compared to other similar algorithms. Okay, so these are just different types of model learnings. Okay, how it is going to learn, whether it is going to generate a model or whether it is going to just learn on the flow. Okay, on the go it will just learn. Okay, that's why it's called instant based. Okay, for each instance it will learn instance by instance and instance to instance. That's it. Okay, it's not going to generalize. Okay, what is the concept of model, guys? When we are generating a model, what does it mean? We are generalizing. Okay, so you learn the pattern from the given data and the model is generated, done. Now this model is responsible for all the predictions on the new test data that is hitting the model. Okay, that is done. But in the instance based, what's happening? No learning is happening here. Okay, so just give me the data, I'll calculate the distance, I'll give you. That's it. No learning, no model generation, nothing. Okay, are we good? Are we good till this point?
Yes, sir.
Yes.
Okay, now going forward. Okay, so we are going to see next general concept in ML called as challenges in ML, guys. Okay, so what are the some frequent challenges which we face? Fine. So once you have a decent understanding on these general concepts, right, then you will be in a better position, okay, to understand when we discuss each model specific concepts. Fine. So post this, in next class, I think we are going to look at a life cycle of a ML. Okay, like end-to-end life cycle of ML. Any project you take, even the sample projects which we are discussing in our course, or a toy data set project, or the actual project, or a fresher project, any ML project which you consider, right, it should follow only these steps. Okay, so then you can correlate with the concept which we are discussing in today's class. Okay, so fine. Now over here, fine. So let's try to understand what are the challenges which we usually face in ML. Okay, first is the data collection, guys. Obviously, right? So because data collection is a big thing. Fine. So fine. So because you just miss. Okay. So because so just give me a second. Okay. Sorry. Fine. Now, first thing is a data collection. Okay. Now coming to data collection. So obviously this is not an easy thing to do because you need to uh like do a lot of maybe manual work or deploy some team, okay, to collect the data, do some surveys, etc., etc. Fine. So data collection will be very cost effective thing. Okay. So any example, so we can take any different types of examples, right? So agriculture you take or some any new product if you want to launch, okay, so obviously you need to collect the data. Fine. And some of the data is confidential, you cannot get the data directly. Fine. And also the source from which we are collecting the data should be reliable. Agree. Fine. So lot of things will be involved. Fine. So and the fundamental step in ML obviously will be the data collection. Fine. Now coming to insufficient data or labeled collection. Okay. Yeah. So as the name suggests, fine. So insufficient data, that means what? So very less amount of data if it is collected. Okay. So as I said in the corona example, so if you want to do some predictions on the corona, but only 10 records are available when compared to 10,000 records of all the previous records. So obviously that is very, very less amount of data, right? So that's insufficient data. Fine. And or the label collection. Okay. What is a label in the sense output variable? Okay. Getting. So you have input X and output Y. Okay. And as I said, input could be anything. Okay. You can have X1, X2, X3, three inputs, but the output will be only Y. Okay. Now, for example, over here, if you're having 10,000 patients data, okay, one problem is insufficient data. That means if you're having only very less amount of data, like only 500, 600, so that is very, very insufficient for the model to train. Okay. The more data you have, it's a fundamental statement. Okay. The more data you have, the better the model will. Okay. Provided the data is a proper data. Okay. It should not be any improper data, but a perfect data, if you're having, so the more data if you have, the better model you get. Okay. It's a simple. Now coming to this label data, that means in out of this 10,000, let's say these labels are missing. Okay. Why? Because if you remember, the label generation is also a big thing. You remember, guys, in previous class I was saying, who's going to create you the label? We, right? So labels are not readily available. Okay. The data is readily available. Okay. You might be getting from system or some survey or from like feedback somewhere you can get, but the rating, the output Y will be should be generated. Okay. So that requires certain amount of effort. Fine. So in some cases, if the label are missing, okay, or labels are not collected, fine, so that will also be a challenge, obviously, because why? As I said, data is a fundamental, or you can say the oxygen for any model, right? So if the data is missing, if even if the X is missing or Y is missing or both X and Y are missing, obviously there is no point. Okay. To collect the data and to collect the proper data and with all proper labels is also one more challenge. Clear? Fine. Next thing is non-representative data. Now, non-representative data in the sense that whatever the data which you collected, if it is not actually pointing to the problem if you are trying to solve. Okay. So for example, let's say in the hospital domain only, fine. So you have, as I said, you want to, okay, you want to do some predictions regarding the disease. Okay. It is related to some hospitals. Okay. So you have created a team. Okay. Some small team of few people. Okay. And you have asked them to collect some similar data. Okay. But let's say they have collected data related to hospital. Okay. But as general data they have collected, that means what is the hospital location, how many employees are there in the hospital, okay, what all tests that this hospital can is having, what are the different devices that are available in this hospital. Okay. This is also related to hospital only. Okay. But not related to specific diseases. Okay. So obviously this is not representing our use case. Our use case is for the disease prediction. Okay, but disease prediction, this is also related to kind of hospital. Okay, but the data what they have collected is very much different from our use case. Okay, so obviously this is not representing our use case, so we cannot train our model on this data. Getting this? Any
Yes,
doubt
sir.
in this top 3 points? Okay, fine. So next is poor quality data, guys. Okay, that means if the data is not proper, what do I mean? Okay, if it is having missing values, okay, and if some of the, yeah, so if it is generally if it is having missing values, and if some noise, if data is present but it is completely noise. Okay, I know you know what is noise, right? So we have discussed what is different outlier and noise. Okay, so due to some manual intervention, someone has added some nonsense data. Okay, or some of the data is not present at all. Okay, so that is poor quality data. Okay, so obviously if any of this is happening, you will not get a good model. Agree, right? Because in machine learning there is a famous line, it's called as, sorry, it's called garbage in, garbage out. Okay, that means what? If you train the model on garbage, it will give you the garbage. It is simple. You give garbage in, it will give you garbage. That means if you give poor data, it will give poor results. If you give insufficient data, it will give insufficient results. That's it. Okay, simple. Next you have irrelevant features. Okay, fine. So that means what? Let's say you have the data, but the features are irrelevant. Okay, so as I said, let's say if you're having as a simple house price prediction. Okay, so the output is like price. Okay, price prediction is my output. Okay, but coming over here, the inputs, if you're having a square feet, okay, that's helpful. Number of bedrooms, number of rooms, that is helpful. Location of the house, okay, that is helpful. But if you're having the name of the person, okay, name of the person or name of the owner, okay, this is irrelevant, right? So obviously common sense says that name of the owner does not have any relation between the price. Okay, if you're having those, okay, if you're having, or age of the person, something related to a person, if you have, these are irrelevant features. Fine, training on this will simply confuse the model. Okay, it will because whatever the data if you are giving to the model, it is always trying to understand the pattern. Fine, but if you pass these features, like let's say if you pass the age, so it will constantly try to learn and like derive some pattern out of the data, but obviously there will not be any correlation, right? It will simply confuse the model and you will get a bad model. Fine, so that's why you should make sure that the features are relevant. Okay, these are features, right? So just reiterating, inputs are also called as inputs, we denote by X. They're also called as features, they're also called as attributes. Okay, or input columns. Fine, the output is called as output, or we denote it by usually Y, and it's also called as label. Okay, or it's also called as target. Okay, fine. Now coming to overfitting and underfitting. Okay, yeah, these are important, guys. Okay, now let's try to understand. Okay, now you are having something called as overfitting, okay, and underfitting. Okay, first let's see overfitting. Okay, so we are going to see this in when we are discussing ML models also, but just to give an idea over here, what is this overfitting? Now fit is what, guys? The word fit, when you hear the word fit in ML, you should understand it as training. Okay, the fit in the sense training. Okay, so that means you are having a data D and the model is getting generated, okay, on this. Now this, what is this? This model is learning the pattern from this data D. Agree? But what is the fundamental goal of training a model? Is it just to train, or to train and then do some predictions? To do predictions, right? Why are we training the model? So that you can use it for some predictions, obviously. Agree? So over here, sometimes what happens over here is the model which you are using, right? Fine. So it will learn it will learn each and every single pattern that is possible in the given data. Fine. And it will have maximum accuracy. Okay, so this is a bit tricky thing, okay, as of now, but just try to understand what I'm saying. So over here, what happens sometimes if the model is learning everything from the training data. Okay, so initially you have training data, right? Training data. If the model is having learning everything from the training data, the problem here is it will not be that perfect to do predictions. Okay, to do predictions on the test data. Okay, to do predictions on the test data. Why? Because what happens over is it has learned so much that it is overfitting. Okay, overfitting in the sense what? It is almost trying to mimic the pattern. Okay, so whatever that means, overfitting in the sense what happens here is you will not be sure whether the model is actually learning something or whether it is by hearting. Okay, by hearting in the sense what? If these are the features, this should be the output. Okay, if these are the features, this should be the output. Agree? So it is just by hearting. Okay, so obviously don't think that the model is not having heart, then how it can by heart. Okay, that means it is memorizing. Okay, it is just memorizing. If these are the input, this will be the output. If this is the input, this is the output. Okay, there is a chance that it can do this. Okay, because if it is getting overfitted, but that is not our goal. Our goal is to learn the pattern, because once the model is trained, but for testing, we are not going to use the same data which we use for training. Both the data will be different. One is called as trained data, one is called as test data, right? So while training, we'll use only trained data, but while testing, we are going to use a test data. Fine. So our goal is the model should work with the maximum accuracy on the test data. Why? Test data is the actual predictions which we are going to get from. Agree? So the goal is that the model should perform excellently on test data. For that to happen, the model should not get overfitted on the training data. Okay, that means what? If it is getting 100% accuracy, okay, if it is learning everything on the training data, fine. So it can be used only for that type of data. If you have a slight change in the test data, it will not work. Okay, because the problem here is it has learned it so well that now it will work only for that type of data. It is not going to work for any other type of data. Okay, so that is an example of an overfitting, guys. Okay, that means it is learning, but it is learning so well that now going forward, it is going to work only for this data. It is not going to work for any other data. Okay, so over here, for example, let's say we are having a small toy data set. Okay, so if you're having a small toy data set, okay, 100 records toy data set. Okay, now on top of this data, if you use a very powerful algorithm, like let's say if you use XGBoost algorithm, fine. So XGBoost is a very powerful algorithm which can work on like some thousands of lakhs of records. Okay, but for example, if you are using for a small toy data set with just 100 records, if you're using XGBoost, it will become an overfitting. Agree? It will become overfitting. Why? Because it learned each and every record. Fine. Now, every record you give from this 100 records, it will work well. But if you give any other record from the test dataset, it will suffer, or it is difficult for the model. Fine. So, learning everything from the input data, each and everything, okay, will also cause problems. Okay. So, that is regarding the overfitting, guys. Okay. Now coming to underfitting, what happens here is the model is not strong enough to learn anything at all. Okay, so you have lots of data, okay, but the model which you have used, it did not learn anything at all from the training data. Okay, that is underfitting. So first of all, if it is not learning from the training data, how can we expect it will work on the test data? Okay, see what are the training data, test data, fine. So you're going to see it soon, but I think at least since Sirisha and Megan, because you're already from the data science background, so you might be already aware of these words. Okay, so that's why I'm telling this. Okay, but if you're facing difficulty in understanding this, Karthik, as of now, okay, just understand that the whole data will divide into two parts. One is training data and test data. Okay, so now training data will be used for training and testing data will be used for testing. That means what? First we will generate the model, create the model on the training data. Once training is done, we will not use the training data again. Now you got the model. Now you use the data which you kept aside, the test data, to do the predictions. Okay, so that's a basic concept. Over here in underfitting, what happens here is the model which you are using, okay, is not strong enough. That means it is not understanding the whole pattern available in the data itself. That means what? Let's say you have a very complex data and you are using a very simple algorithm called as linear regression. Okay, linear regression you're using. So over here, what happens, guys? What happens? So now what is the nature of linear regression? It just to draw a line, fine. But the data is too complex, fine. Even if you draw a line, something like this, okay. So it is losing most of this data. What is this? This is all the information, right? What is data fundamentally? It's some information, fine. So if you're using a simple algorithm on a complex data, fine. So obviously the model which you are getting will be underfitting. That means underfitting means what? What is required, you are not reaching there itself. Then how can you expect that it will do predictions? First of all, if you learn something, then you can write something, right? But if you're not learning anything, so how can you expect this to do some predictions? Getting? So in these cases, it will be underfitting. Okay. Are you guys following?
Yes, sir.
Others?
Yes,
Doubt?
sir.
Okay. See, I'll give you a simple example. You will understand. Okay. See, overfitting, what happens means, let's say I'm saying the model has learned. Okay, that is fine. But it is learning so well. It is learning so well. Now, it cannot perform on the unseen data. Okay. Now, what is unseen data? Test data. Okay. Simple. Okay. So this I'm going to discuss again in the like machine learning concepts. Okay, when we are coming over there, but just to give an example. So see, focus on this example, you will understand. See, let's say, as I said, a model. Okay, so you have the training data, the model. You using this training data, you will generate this model. Okay, after that, you will pass the test data. Okay, you will pass the test data. Okay, and you will get the predictions. Okay, this circle, okay, is regarding the data generation, also predictions. Okay, you are going to see this many times. Okay, so now what is happening? The model is getting generated. Okay, now if this model which is getting trained on this training data, fine. So if it is learning so well, okay, so well, then what happens is it can understand only this data. Okay, it can understand only this data, fine. So if I pass a new test data, okay, so I'm not sure whether it will work or not. Okay, because for example, let's say, see, yeah, fine. See, how can I tell this? See, if model is there, training is done. Agree? Now, while testing also, focus on my words, guys. While testing also, if you use the training data only, again, if you use the training data only again, okay, you might get good results. Okay, you might get good results. Why? You train the data on this training data, and on the same data also you are using for the testing also. Obviously, there are more chances to get good results. Okay, we'll go step by step. Do you agree with this point? If you use the same data for training and also testing, the results might be better. Do you agree or not with this point? Okay, see, try to understand what I'm saying. I'm saying there is some data, okay, and using the data, you have generated the model. Now this model is already exposed to the training data. Already it has seen every pattern from this training data. Fine. Now while testing also, you are using same data, and again you are asking the model for some predictions. Now it is doing some predictions. Okay. Now these predictions will be obviously better. Okay, when compared to let's say a model is there, you are using the training data. Okay, but for testing you are using what? You are using the test data. You're using test data. Okay, this data is different, this data is different. Okay, and it is doing predictions. Okay, now observe here I'm using the I'm training the model on the data, training data, and again for testing also I'm using the same training data. Okay, here I'm using the training data, one type of data, and there is some completely different data called as test data. I'm using this for the predictions. Now in which case you think the predictions will be better?
Training will give training data, and for testing also if we use training data.
Excellent. Why?
As it is already trained on that data, if we use the data, it will give correct results.
Super. Correct. Fine. So because it has already seen the pattern, okay, if you give this again, it will give the but excellent. Now, but what is the fundamental point of training the model? Is it to test it on the same data which we have trained it? No. The goal is it should work on the unseen data, which is test data. Agree? The goal is training data is required only for just training. Okay, once the model is generated, the goal is we can use it for some testing. That means this is completely unseen data. We don't know from where this test data we are going to get. Okay, so we will divide, but just assume while training the model has never seen this data. Okay, from model's point of view, this test data does not exist till the model is generated. Okay, the only training data is existing. Okay, so once it is generated, then we are suddenly bringing this test data and we are asking for the predictions. Okay, now in this is our goal. This is our goal. Now the problem here is in the overfitting, what happens is if the data is trained so well, then it will understand only training data. It can do predictions only on the training data. That means the training data accuracy will be high. It cannot work on the test data. That means, for example, let's say you studied intermediate, fine. In intermediate exams, what happens is mostly whatever you study in the in your class, same thing you'll be asked in the exam. Agree? So what are the chapters, or most of the what are the questions will be repetitive in the, at least if you study from last 3 or 4 years, same type of questions you get. Okay, even if you don't understand the answer, if you just by heart, if you just memorize, and luckily if you if you get that question, if you write it down, you'll get marks and you'll pass. Agree? Okay, that's happening. That is a probability that can happen in the training data. Over here it can just memorize the data. Okay, that means, see, if it is giving 100% accuracy, so that means you'll be surprised that it is just memorized. The model is just memorizing whatever you are giving. It is just memorizing, and then it is giving you the answer while you are giving some predictions. Okay, but the goal is not that. The goal is to work on the unseen data. Okay, so when you will know, but if you see in the entrance exams like IIT or NIT exams, so there whatever you have learned, you're not going to get questions from there. Okay, the concept will be same, but the questions will be different. Fine. Even if you practice 1,000 questions, the questions which appears in those entrance exams will be completely different. Fine. If you are working, okay, if you are performing well on that type of data, okay, on the exam data is an unseen data. It's a test data, right? That's why it's called test. Fine. If you're working well over there, and if a performance is more, okay, if a performance is excellent over there, that means you are a good student. Agree? Over here, similarly, if the data is working better on the test data, unseen data, obviously, it is a good model. Agree? So to do that, the model should not be overfitted. Okay. So, but understanding this much at this level is fine. But when we come across this concept, right, then I will actually show you what is the in detail. That means how we divide the data into trained data, test data, and what is training accuracy, what is testing accuracy, and where exactly this overfitting, underfitting will come. Okay, then you will understand it in a better way, guys. Okay. Don't worry if you don't understand it 100%. Okay, but at least you got some idea, right? So what I'm trying to explain you, fine. So what is overfitting and what is underfitting? Fine. And underfitting in the sense that the model is not strong enough. Okay, that means for some very strong classification, if you're using a basic simple algorithm, okay, obviously it cannot understand the whole pattern itself. Okay, so that will be underfitting. Okay, so trust me, when we are discussing about the trained data, test data, so I'm going to discuss these two concepts again, and at that time it will be crystal clear to you guys. Okay, don't worry. Okay, but from the concept which you have discussed now, are you able to understand few things? And any doubts, guys? Overfitting, underfitting? No? All clear? Everybody? Okay, great. Fine. So that is regarding the overfitting and underfitting. Okay, so after that, the few things like software integration, deployment, and cost involving. Okay, so these are like general challenges which we have, because see, it's coming to software integration, right? So and deployment. So if I speak combined, so the model generation, everything, so all the efforts which you are putting, that is fine, done. Okay, but once it is done, obviously you cannot put it in your system. Okay, or wherever you have trained, so you need to pass it, or you need to deploy it somewhere. Okay, you need to, and during deployment you will integrate it with many other tools, right? So because your model is not just one thing. Okay, it is just one thing in the whole picture. Okay, so see, we are focused in this ML world, right? So this is big for us. Okay, once you generate the model, once you come out of this, and if you submit this to your client, so what does client do? You'll just take this model and put it in one server, and in 100 things that is happening in his pipeline, right? Our model is just one thing. Okay, that means what? Apart from these predictions, also the hospital, that pipeline will have hundreds of things, right? So some testing might happening, some automation happening, so etc, etc. Fine. In that, our just one model will be just one thing. Fine. So if your model should work, right, so it should be integrated with lots of other things which are already existing in that pipeline, right? So it cannot stand alone. Fine. So there you might require some challenges, because there will be some compatible issues or some cloud issues you might face. Okay, etc, etc. Okay, it is specific to that. Okay, and deployment also, yeah, for deployment also some changes. Usually you can deploy in different platforms. Okay, so the famous, as of now, today famous, the clouds are like three. Fine. So one is Amazon. Okay, AWS cloud, which you have seen, not seen, so which you might be aware. Okay, and second thing is from Google, called as GCP, Google Cloud Platform. Okay, and third thing is Azure. Okay, Microsoft Azure. So out of these, mostly three are famous. Okay, but I see AWS, most of the people are using AWS. Okay, and it is very, I use AWS and it is very user friendly. Okay, and Azure, most of the people are also using Azure. Okay, GCP, personally I do not see. Okay, but whatever I have seen is very small percentage. But from whatever I've seen, whatever I heard, and whatever I have read, okay, so AWS and Azure, a lot of the people are using. Okay, apart from that, there are also some open source platforms where you can deploy your ML models. Okay, so for example, if I show you, there's something called as Pivotal. Okay, so you have something called as Pivotal. Oh, not Pivotal. GCP is Google Cloud Platform. Pivotal. Sorry, software deployment. It's a Pivotal only, guys. Okay, so Pivotal platform. So here also you can log in and deploy your model. Okay, so or you also have something called as Heroku. Okay, Heroku deployment. Okay, these are free. So Heroku deployment development center. Okay, so here you can deploy, monitor, continuous deployment. Okay, so that means what is deployment? So you are placing your model in some server so that you can directly get some predictions. Okay, so if time permits, I will try to show you one deployment also. Okay, so maybe Heroku or something. Okay, but however, in our project we are going to see deployment. So in our project we are going to see web UI deployment. So where the model is generated, right? So you can use it that as a web UI. Okay, so yeah, so we are going to see over there, based upon the platform you are using, based upon the softwares which are already existing, you might face some integration problems. Okay. And coming to cost involved, obviously what everything finally boils down to cost. Okay. So that means what? So every time you train a model, right? So if it is running in the cloud, so you need to pay some charges to AWS. Okay. So obviously it's a cost involved. So that's why so usually you take some instances in the AWS. Okay. That means you will how do I tell you the instances? Okay. So you will buy some storage. Okay, because whatever that, obviously you should store your data, right? So and whatever the results you are going to get, you need to store those models, or you need to store. So storage is the first thing. Okay, fundamentally you will buy some storage from the AWS platform cloud. Okay, and then you will store your data, and then you will buy some other service for each service. So there are like lots of AWS services, guys. Okay, just to give you an idea about AWS, right? So just if you go to AWS, fine. So over here, yeah, see, you have AWS EC2 instance, okay, where you can train your virtual servers. Okay, so here you can servers in the servers you can train your models. Okay, see it. So I was you have something called AWS Lambda, run code without thinking of servers. Okay, Lambdas, it is almost servers, so where you can just put your plain Python scripts, okay, to run the models. Okay, so I was using this AWS Lambda, and then you have something called as S3. Okay, for example. Okay, so see, AWS simple storage services. Okay, it's called S3. Okay, they're called S3 buckets. Okay, wherever you want to store your data. Okay, so like that, for each and every service you use, right? So you should pay something. So obviously you should keep that also in your mind. So okay, unnecessary data you should keep on deleting. Okay, and unnecessarily you should not run your models. Okay, so experimentation, all your experimenting, right? So you should be little cautious, because whatever every second you are in cloud, so obviously you should be paying something to the AWS or whatever the platform you're using. Okay, so it's obviously a cost involved thing. Okay, and there are some models. Okay, so if you're not aware, so usually there are some models so which runs for some days, right? So if it is working on, if the data is huge, okay, or there is some concept called as hyperparameter tuning, guys. Okay, so which we'll be seeing. Okay, so there, each model will have certain parameters. Okay, so model is simple, you can directly what is import it from some module, but related to the model there will be hundreds of hyper parameters. Okay, you can just call it a simple word settings. Okay, so to find out the best type of settings so that it will give you the maximum accuracy, right? So you need to do a lot of experimentation, different permutation combinations. Okay, so for that it requires a lot of time, so much energy, effort, and resources, right? So it usually, if it is a huge data, the model runs for some days together. Okay, so obviously you need to pay a lot. Okay, so all this involves so much cost. Fine, so usually these are the challenges which we face in ML. Okay, and these are the general challenges. Okay, so these are not specific data related challenge. Okay, when we speak about the data specific challenges, there will be like how to handle all those data drawbacks, like missing values or outliers or scalings or etc. Okay, that is specific to data. Okay, but these are general, okay, point of view challenges. Okay, collections, right? On collections, okay, irrelevant, overfitting, underfitting, cost involved. Fine, so yeah, guys, so these are the concepts which we have for today. Fine, so I hope you followed. Fine, yeah, so in next class, mostly we are going to see uh, okay, we are going to see the life cycle, okay, end-to-end life cycle of one ML, so that once you have this idea, right, so any concept which I'm going to this will be fitted somewhere in this life cycle. Okay, so whether you take feature engineering or EDA or model training, validation, accuracy, whatever you take, it will be fitted somewhere in this life cycle, obviously. So once you have the overall picture, right, so it is very very easy for us to for you to correlate any new concept I am saying. So you'll understand where you can put this concept, whether whether I'm talking about model validations, or whether I'm talking about algorithms, or whether I'm talking about feature engineering, you will understand. So once you have a 360-degree view, right, so obviously it will be very better, right? So that we are going to see, and once that is done, then I think in next class mostly we can start with basic EDA and feature engineering. Okay, so once you have that slow understanding how to handle data, right? And because you already have tools. What are the tools you have, guys? You have the different tools as of now you have in your hand are Python, Stats, NumPy, Pandas, Matplotlib, Seaborn. All the things you see we studied over here along with Python. Those are the tools available. Okay, now you can use them and extract some or do some analysis. Fine. So yes, guys, these are from my end today. Okay, any doubts, guys?
No, Santosh.
Okay, cool. So chalo, thanks guys. Bye. Let's meet in our next class.
Sure.